But hold on tight, because we're about to take things to a whole new level. If you thought the Milky Way was big, wait until you hear about the observable universe. The observable universe has a diameter of roughly 93 billion light-years. Let's repeat that. 93 billion light-years. This is the region of the universe that we can actually see. But why can we only see this much? Well, it's all about light travel time. Think about it. We only see objects if light reflecting off them reaches our eyes, or more accurately, our telescopes. Since light is the fastest thing in the universe, we couldn't see anything that's farther away than 93 billion light-years, because no light from those distant realms has had enough time to reach us yet. In other words, the universe is expanding, pushing distant galaxies away from us faster than light can travel. That means that the most distant galaxies we can currently see are so far away that their light has been traveling for the entire age of the universe to reach us. Now, before we continue, we want to remind you that there's more to the universe than just what we can see. Sure, the observable universe is pretty mind-blowing, but it doesn't necessarily represent the entire cosmos. Some scientists theorize that the actual universe is infinite, meaning it never ends. Others believe that it could be finite, but much, much larger than the observable universe. Who knows? Maybe there are even more galaxies, stars and planets beyond our current view, just waiting to be discovered. Some theories suggest the existence of a multiverse, a vast network of parallel universes that exist outside of our own. These hypothetical universes could have their own laws of physics, constants, and even dimensions. While these ideas may sound like science fiction, they're actually rooted in some pretty legit scientific theories, including inflation and string theory. Inflation posits that the universe went through a period of exponential expansion in the first fractions of a second, after the Big Bang. Meanwhile, string theory suggests that there could be multiple dimensions beyond the four we experience, meaning there could be other universes existing alongside ours. It's important to note that these are just theories, and there is currently no way to prove or disprove their validity. But that hasn't stopped scientists from exploring these concepts and trying to unlock the mysteries of the multiverse. Some researchers believe that the multiverse theory could provide an explanation for certain cosmological anomalies, such as the universe's large-scale structure and the abundance of matter over antimatter. Others think that string theory could help resolve some of the biggest problems in physics today, such as the conflict between general relativity and quantum mechanics. Whatever the truth may be, one thing is certain. The universe is truly vast and mysterious, and there's so much more to discover. It's hard to wrap your mind around the concept of infinity, or something being bigger than infinity. But if you really want to put our cosmic backwater into perspective, consider this, according to some estimates. The actual universe could be as much as 250 times larger than the observable universe. That means there could be trillions upon trillions of galaxies, stars, and planets out there beyond our current view. We might have barely scratched the surface of what's out there, which makes the universe truly mind-boggling in scale. We've traveled to distant galaxies and back, all from the comfort of our own living room. We've seen what it would look like if we were the size of an atom and shrunk down to the tiniest building blocks of matter. We've explored the unfathomable vastness of the observable universe and considered the possibility that it is just the tip of the iceberg in a much, much larger cosmos. So here we are back on Earth, our little blue planet in a solar system that is just a tiny part of a galaxy that is only one of countless trillions in a potentially infinite universe. We're just a speck in a universe far larger than our imagination can grasp. And yet, despite our smallness, we've managed to unlock some of the universe's greatest secrets and explore more of the cosmos than any other species throughout history. Maybe our smallness is what makes us so incredibly special. Reminds us that we're just a tiny part of something much bigger than. Did you know that our home planet Earth is actually quite young? Geologists say that it was formed about 4.5 billion years ago from a giant cloud of cosmic dust. Here's how they think it happened. 4.5 billion years ago, our solar system was a big hot mess. There was a lot of stuff floating around, a bunch of rocks and dust, and they were all orbiting around the sun. Over millions of years, some of this dust and rock started to clump together. And if you have an idea of how planets form in general, you might think, okay, cool, Earth just kind of coalesced out of this dust. But that's not what happened. Instead, a Mars-sized planet smashed into Earth while it was still forming. This caused a bunch of material to get blasted out into space. Over time, some of that material coalesced into the moon. Now, Earth had oceans, but how did those form? Well, here's what we think happened. As Earth cooled, it started to release gases that had been trapped inside, like water vapor and carbon dioxide. These gases formed a very thick atmosphere. Meanwhile, other stuff was also coming to Earth. Comets made of ice and rock were attracted to Earth's gravity and crashed into the planet. Over time, these comets brought so much water to Earth that it raised the sea level by more than 600 feet. So that's how we got our oceans. Okay, so we have a solid or liquid theory on how Earth got its features. But how did conditions on Earth get so? Well, Goldilocks? How did we end up with an atmosphere that is just the right amount of gassy? Enough water, but not too much water, and a temperature that is just right for life as we know it. Scientists don't know exactly how this happened, but they have a few ideas. One idea is that Earth's early atmosphere protected the planet from harmful radiation. It's given off by the sun. The radiation would have stripped away any water vapor in the atmosphere, leaving behind only the more substantial gases like nitrogen and carbon dioxide. Another idea is that Earth's magnetic field played a role, could have helped retain our atmosphere and gave life a chance to take hold, by the movement of electric charges within a planet and on Earth. This happens thanks to the churning of our planet's core. If Earth didn't have this churning, or if it didn't have an atmosphere to begin with, it's likely that the solar wind would have stripped away our atmosphere and left Earth as a barren, lifeless rock. Then there's the possibility that the moon protected Earth from the worst of the sun's radiation, allowing life to flourish. Or maybe it was the moon's gravity that helped Earth get its nice, stable atmosphere. In general, planetary scientists think that the moon got where it is now because Earth and the moon did a little gravitational dance. After the big collision that formed the moon, Earth and the moon were orbiting each other really close. Eventually, though, Earth's gravity won out and pulled the moon into its current position, farther away from Earth. This may have happened gradually, or it may have happened quickly. Either way, having the moon where it is now helped Earth keep its atmosphere. It might seem like a long time for something to happen, like billions of years. But it turns out that the stuff that led to the formation of Earth and the moon was happening pretty quickly. In less than 1 million years, Earth went from being a hot ball of magma to being a planet with an atmosphere and oceans and a moon in orbit. That's a lot of change in a, geologically speaking, short amount of time. So thanks to all the stuff that collided with Earth, including the mysterious planet that gave us the moon, and thanks to all the comets that crashed into Earth, delivering the water that made our oceans, we owe our existence to all of that. If you want to learn more about how Earth changed over time, you can check out the Crash Course Geography series, which starts with the formation of our planet and goes through everything that has shaped it, including humans. You'll get to learn about plate tectonics, the rock cycle, and more. Our universe is full of monsters, and one of the scariest is the black hole. These cosmic entities are so bizarre that they defy easy explanation. And yet they're probably not what you think they are. Here's what black holes have in common with unicorns. Neither of them are real. Well, maybe that's a bit too far. We do have evidence that strongly suggests black holes exist, but we've never seen one for certain. Black holes are best described as regions of space with gravity so strong that not even light can escape their grasp. But how do these cosmic vortices come into existence? The leading theory is that they form when massive stars collapse at the end of their lives. If a star is massive enough, around 20 or 30 times the mass of our sun, when it collapses, it will literally crush itself. Under such extreme pressures, matter gets squeezed together to form incredibly dense objects known as neutron stars. If the star is even more massive, say 50 or 100 times the mass of our sun, then not even neutron degeneracy pressure can resist the pull of gravity, and a black hole will form. It's also important to note that while the interior of a black hole is extremely hot, its surface, if it can be called that, is actually completely black. This is because no light or any other electromagnetic radiation can escape the intense gravity well of a black hole. As a result, black holes can't be observed directly, only indirectly, through their effects on nearby matter. The first indirect evidence for black holes came in the 1970s, when astronomers noticed some stars orbiting something invisible in space. They could see the stars wobbling as they passed in front of the invisible object, but they couldn't see the object itself. Since they knew it had a very large mass, based on its gravitational effects, but it was invisible. They concluded that it must be a black hole. Now, because we can't observe black holes directly, there's some debate about what exactly defines one. Is it the size of the region from which nothing can escape, known as the event horizon? Or is it the boundary of the area within which matter has collapsed? Because of this, there isn't complete agreement on just how many black holes exist in the universe. Some astronomers believe there could be billions, trillions, or even more. For most of human history, black holes were purely a matter of theory. But in 2019, astronomers announced that they had taken the first ever photo of a black hole. It was captured by the Event Horizon Telescope, a global collaboration of researchers, and was published in the journal Astronomy and Astrophysics. The image shows the glowing orange material around the black hole at the center of the Messier 87 galaxy, which is located 55 million light-years away. The orange ring is not the actual black hole, but rather the superheated gas and dust that's been pulled in close to it. Since nothing can escape a black hole, not even light, we can't see inside it. The photo shows us what lies around a black hole, not the black hole itself. To date, all confirmed black holes are incredibly distant. In fact, the nearest one to Earth is more than 3,000 light-years away. Fortunately, there doesn't seem to be any immediate danger of a black hole appearing in our cosmic neighborhood. That would require a star cluster of hundreds of thousands of solar masses to suddenly collapse, which is astronomically unlikely. Did you know that our planet is shaped like a sphere? I mean, it's not a cube or a pyramid or anything else. It's a sphere. And there's a reason for that. Can you name that reason? Still thinking, well, here's a hint. It's all around you right now. In fact, if you were to leave your house right now and walk toward any direction, odds are pretty good you would end up knee-deep in it within about a mile or so. Talking, of course, about the sea. The ocean, because it covers more than 70% of Earth's surface, is the reason why our planet is a sphere. But the sea does a lot more than just define our planet's shape. It also drives our climate and weather patterns, produces most of the oxygen we breathe, and is the reason why we have monsoons, currents, and even some types of storms. The sea is also a major part of the water cycle and provides us with food, energy, and other resources. So let's dive into how the sea shapes our planet. Hey there, welcome to this channel. The sea does a lot for us, but one of the biggest things it does is produce oxygen. Did you know that phytoplankton, which are tiny plants that live in the sea, produce about half of the oxygen we breathe? That's because when they perform photosynthesis, they release oxygen as a byproduct. And since there's so much sea on our planet, that means there's a lot of phytoplankton, which in turn means that our oceans produce a lot of oxygen. But speaking of the sea's role in producing things, you can also thank it for giving us water, or more specifically, for giving us rain and snow. That's because the sea plays a big role in the water cycle. When the sun shines on the sea, it evaporates some of the water, turning it into vapor. That vapor then forms clouds, which can then get so heavy that the water falls back down to Earth in the form of precipitation. And depending on how cold it is, that precipitation can be in the form of rain, snow, sleet, or hail. This process is called the water cycle, and it wouldn't be possible without the sea. Now, the sea doesn't just give us water, it also gives us a lot of weather. The currents in the sea help to regulate our planet's climate. For example, the Gulf Stream is a current that carries heat from the Gulf of Mexico up to Europe, which helps to keep the continent warmer than it would be otherwise. Without this current, Europe would likely be a lot colder and have a very different climate. Speaking of currents, you can also thank the sea for some of the storms we experience. Storms get their energy from temperature and pressure differences in the air. And one of the biggest temperature differences on our planet is between the land and the sea. As you probably know, land heats up and cools down much faster than the sea does. So when a storm comes along and starts to form, the sea provides the energy it needs to get started. Once a storm starts to form over the sea, it sucks up warm water vapor from the surface. As the vapor rises, it cools, which forms clouds and also causes even more vapor to get sucked up, and it gets stronger and stronger until, bam, hurricane. The sea is also responsible for some other weather phenomena, like monsoons. Monsoons are seasonal wind patterns that cause heavy rainfall in certain regions. They happen because of the temperature difference between land and sea. During the summer, the land heats up much faster than the sea does. So the air over the land rises, and cooler air from the sea rushes in to take its place. When the air reaches the land, it cools, which forms clouds and causes even more rain. Oh, we haven't even mentioned what the sea does for us. Not only is it home to a lot of the oxygen we need to breathe, but it also gives us food, energy, and other resources. For example, the sea is a major source of protein for billions of people. What's really strange is that despite these extreme conditions, life still exists down there. In the Mariana Trench, you can find bizarre fish with huge mouths and sharp teeth like the anglerfish, which has a glowing lure that it uses to attract prey in the darkness. It dangles this lure in front of small fish, and when they get close enough, anglerfish gobble them up. But the anglerfish isn't the only strange creature lurking in the deep sea. There are also giant squid with massive eyes that can spot prey from far away. They have such big eyes because light is so scarce down there that even the tiniest glimmer can help them find something to eat. But the deep sea is mostly filled with animals that can produce their own light. Bioluminescence, as it's called, isn't just pretty to look at. It's actually a useful tool for survival. Some animals use it to attract mates, while others use it to lure prey or to confuse predators. For example, the hatchetfish has a light under its chin that helps it blend in with the faint light filtering down from above. This way, predators can't see their silhouettes, and they're less likely to be eaten. But the deep sea isn't just full of weird animals. It's also full of weird rocks. Hydrothermal vents, as they're called, are areas where superheated water comes out of the ocean floor. They're usually found near volcanically active areas, and they can reach temperatures of over 400 degrees Celsius. That's hot enough to kill most living things. Yet some animals have figured out how to not only survive in these extreme conditions, but thrive. For example, giant tube worms have been found growing around hydrothermal vents. These worms don't need sunlight or even mouths to survive. Instead, they have bacteria living inside of them that convert chemicals from the vent into energy. Exploring this extreme environment hasn't been easy, but thanks to technological advances, we've been able to learn more about the deep sea than ever before. The first manned submarine was invented in the 16th century, but it wasn't until the 20th century that we started exploring the deep sea. Today, scientists use a variety of submersibles to explore the deep sea, including remotely operated vehicles or ROVs. An ROV is basically a robot that can be controlled from the surface. It has cameras and lights to help scientists see in the darkness and robotic arms that can collect samples. One of the most famous ROVs is named Deep Sea Challenger. It was used by filmmaker James Cameron to make a record-breaking dive to the bottom of the Mariana Trench in 2012. So why do we even bother exploring the deep sea? It might seem like a vast, dark, and dangerous place, but it's also incredibly beautiful and mysterious. We've only scratched the surface of what's down there, and who knows what other strange and wonderful things we might find. Maybe we'll discover new species of animals, or even new forms of life. Or maybe we'll find evidence of ancient shipwrecks or lost cities. So much in the oceans. In the water, there is little oxygen. It's hard to get food and sunlight can't penetrate very far, making photosynthesis impossible for most organisms. But over the past 600 million years, some animals have overcome these challenges and have thrived in the water. So let's take a moment to learn about some of the animals that call the ocean home. Welcome to life on the ocean's edge. So there are obviously a lot of different kinds of sea animals. There are fish, like salmon and clownfish, mammals like dolphins and whales, reptiles like turtles, and even invertebrates like jellyfish. In fact, scientists estimate that there could be as many as 200,000 different kinds of sea animals. To put that number in perspective, there are only about 8,700 known kinds of land vertebrates. And just like on land, sea animals tend to live in groups. You've probably heard of schools of fish, but did you know that some animals like crabs and lobsters tend to live in what's called a guild? A whale pod might contain hundreds of individuals, and a crab guild can contain dozens. Jellyfish, on the other hand, tend to congregate in what are known as blooms, which can sometimes cover the surface of the ocean like a floating purple carpet. One of the reasons sea animals can live in groups is because they need each other to survive. Take coral reefs, for example. While they may look like rocks, corals are actually made up of tiny animals called polyps. These polyps live together in massive colonies, connected to each other by a structure made of calcium carbonate. The polyps capture plankton and other small floating organisms with their stinging cells and use them as food. In fact, coral reefs are kind of like underwater cities, teeming with thousands of different kinds of sea animals. Not only do these sea animals have to compete with each other for food, but they also have to contend with predators. Fish like sharks and whales eat smaller sea animals, and even sea turtles are occasionally eaten by large sharks. In fact, there's a symbiotic relationship between whale sharks and dolphins. The dolphins will eat the smaller fish around a whale shark, cleaning it of parasites, and the whale shark provides the dolphins with protection from predators like tiger sharks. Humans are also a threat to sea animals. We often kill whales and dolphins by getting our fishing nets and lines tangled around their bodies. And in some places, people hunt sea turtles for their shells and meat. Plastic waste dumped into the ocean also poses a serious threat to sea animals. Sea turtles often mistake plastic bags floating on the water for jellyfish, a favorite food of theirs. And when they eat the bags, it blocks their digestive system and kills them. But despite all these threats, there are still plenty of sea animals living in the ocean today. And it's thanks to their ability to adapt to constantly changing conditions. Take the mimic octopus, for example. This amazing creature can change its shape, color, and texture to blend in with its surroundings. This helps it to ambush its prey and also to avoid being eaten itself. Another example is the blue whale, the largest animal on planet Earth. Blue whales can dive to depths of 100 meters or more in search of krill, a small crustacean that lives in the ocean. By diving deep, they can avoid being seen by predators and also find plenty of food. There are also animals like the hagfish, which is a type of eel-like fish that lives on the seafloor. Hagfish have no bones and can squeeze through tiny openings in the seafloor in search of food. They also have special teeth that allow them to slice through flesh with ease. As you can see, there are all kinds of amazing animals living in the ocean. From the smallest jellyfish to the largest whale, each animal has unique adaptations that help it survive in this challenging environment. And while some species are threatened by human activities, there are still plenty of animals thriving in the ocean today. People settled near it, traded over it, and fought over it. It inspired some of our greatest myths and legends and took some of our greatest heroes. Here's the history of human and the sea. Before we had airplanes or even cars, people traveled by boat across the seas to get to new lands and trade with other cultures. Some of the most important ancient sea trade routes included those along the coasts of Africa, the Arabian Sea, and the South China Sea. In the Mediterranean, Greek and Roman ships would travel to far-off lands carrying goods like olive oil, wine, and silk. The Vikings were also famous for their seafaring adventures. They traveled all over Europe and even North America long before Columbus. But that brings us to one of the most famous explorers in history, Christopher Columbus. He was an Italian explorer who was the first European to reach the Americas in 1492. He sailed west across the Atlantic Ocean in search of a faster route to Asia, but instead landed in the Caribbean. His voyages and the voyages of other explorers who followed him are considered a pivotal moment in history. They opened up the Americas to colonization by Europeans and began the process of globalization that continues today. Another famous explorer was Zheng He, a Chinese admiral who led 7 voyages to Southeast Asia, India, and Africa between 1405 and 1433. His fleet was massive, consisting of hundreds of ships and thousands of sailors. They were the largest ships ever built up to that point in time and traveled over 40,000 miles. These voyages were part of a larger effort by the Chinese government to expand its influence and trade networks. They brought back to China many exotic animals and plants from other lands. Another famous explorer was Ferdinand Magellan, a Portuguese explorer who led the first circumnavigation of the globe between 1519 and 1522. His crew sailed over 69,000 miles and crossed the Pacific Ocean for the first time. This voyage proved that the Earth was round and that there was no land to the west of the Americas. But it wasn't just explorers who braved the seas. Many famous battles were fought on the ocean, such as the Battle of Actium in 323 BC, where Octavian defeated Mark Antony and Cleopatra, the Battle of Lepanto in 1571, where the Spanish and Portuguese fleets defeated the Ottoman Empire, and the Battle of Cape St. Vincent in 1797, where the British Navy defeated the Spanish and Portuguese fleets. These battles were important because they helped to shape the balance of power in the world and determine the fate of empires. The sea has also been a source of many famous myths and legends. One of the most famous is the legend of Atlantis, a mythical island civilization that was said to have existed in the Atlantic Ocean. According to Plato, Atlantis was a place of wisdom and enlightenment, but it was destroyed by a natural disaster. Other legends include the story of Sinbad the Sailor, who went on 7 voyages and encountered mythical creatures from the Old Man in the Sea to the Kraken, a giant squid monster that could wrap its tentacles around a ship and drag it down to the bottom of the ocean. Mermaids have also captured the imagination of people for centuries. These mythical creatures are said to be half human and half fish and live in the sea. Today, the ocean is still an important part of our lives. Modern ships carry goods and resources all over the world and help to connect different countries and cultures. The invention of new technologies like GPS and satellite communication has made it easier and safer to travel on the sea. But despite these advances, the ocean is still a dangerous place. Storms, shipwrecks, and piracy are just some of the dangers that sailors face today. One of the busiest stretches of water in the world is the South China Sea. Every year, hundreds of trillions of dollars worth of goods are shipped through this area. That's why it's so important to keep the sea routes in the South China Sea open and safe. Unfortunately, there are people who want to disrupt the peace in the South China Sea. In recent years, there has been a lot of tension in the South China Sea. Many countries have been fighting over the islands and waters. This has led to a lot of worry about what might happen next. Some people are concerned that there could be a war in the South China Sea. They say that if something happens to the cargo ships, it could cause big problems for the world economy. That's why it's so important for everyone to work together to keep the peace in the South China Sea. We all need to make sure that the ships can travel safely so that we can keep trading with each other. You might think of the ocean as an endless blue expanse, something so vast that it'll be around for a very long time, in which we not doing that much harm to. But our oceans are in peril. They're drowning in plastic, warming at an alarming rate, being fished to the point of collapse, and becoming more acidic as they absorb carbon dioxide from the atmosphere. And it is up to us to reverse this trend before it's too late. Hi, I'm here to talk about what will happen to our oceans in the future. First, let's look at some scary statistics. Every year, humans produce 275 million metric tons of plastic waste. Some of that gets recycled, but most of it eventually finds its way into the ocean, where it kills an estimated 1 million seabirds and over 100,000 marine mammals every year. Much of the plastic waste in the ocean comes from discarded fishing nets, which can smother coral reefs or become tangled around whales. Meanwhile, the ocean covers more than 70% of Earth's surface and absorbs 90% of the planet's excess heat. As a result, average sea levels are now rising by about 3.6 millimeters per year. And ocean temperatures are rising too, leading to coral bleaching and less snow and ice in the Arctic. Some fish species have already been pushed to the point of extinction, and many more are in danger. For example, overfishing has reduced the population of Atlantic cod off the coast of New England to just 1/10 of their former abundance. But it's not all doom and gloom. There are organizations out there taking steps to protect our oceans. For example, in July 2021, a group of engineers set a new world record by removing 30 million pounds of plastic from the water in a river cleanup project in Indonesia. This was the largest ocean plastic cleanup operation ever carried out. So what does this all mean for the future of our oceans? Well, it depends on what we do today. Let's discuss 3 steps we can take to reduce our plastic consumption. Less plastic we use, the less will end up in landfills and incinerators, and choose eco-friendly products. Look for items made from recycled materials, or which are themselves recyclable. Also avoid single-use plastics like straws and cutlery. Instead, use reusable bags, bottles, and coffee cups. If we all do our part to reduce plastic consumption, then less of it will end up polluting our oceans. 2, we can protect ocean habitats. Coral reefs are some of the most diverse ecosystems on Earth, but they're under threat from climate change, pollution, and overfishing. We can help by supporting organizations that are working to restore damaged coral reefs and create marine protected areas where fishing is banned. One group of engineers has developed machines that can quickly grow new coral reefs in shallow coastal waters. These artificial reefs can then be colonized by corals, providing new habitat for fish and other marine life. Another organization works with local fishermen to create no-take zones in areas where fish populations have collapsed. By giving fish populations time to recover, these zones can help restore entire ocean ecosystems. And finally, we can make changes in our own lives. If you live near the ocean, you can get involved in beach cleanups or work with a local organization to monitor the health of the ocean. If you don't live near the ocean, you can still make a difference by reducing your carbon footprint. The less carbon dioxide we emit, the slower sea levels will rise, and the less damage there will be to fragile ocean ecosystems. You can also support organizations working to protect the ocean by donating money or volunteering your time. In the future, our oceans will continue to face challenges, but with our help, they can thrive once again. So what will the future of our oceans look like? That's up to us. Will we continue down the same path that we are on today, or will we take action to protect the ocean? It's up to all of us to decide what kind of future we want for ourselves and for the planet. So let us hope that we make the right choices so that our oceans can continue to thrive for generations to come. Thank you for watching this video. If you enjoyed it, please like and share it with your friends. And if you want to learn more about the ocean, check out the links below.